In this problem, we will find the computation of a function and the inverse. First, the inverse will give us an angle, so we will let this equal to theta. That's where we start. Next, we take the cosine on both sides, so cosine on both sides. That gives us a u. We then draw a little triangle, right triangle. Let theta be that acute angle. Cosine of something is adjacent over hypotenuse. And in previous ratio we have u, why don't we write u over 1? So we match u is adjacent, 1 is hypotenuse. So adjacent is going to be u and hypotenuse is 1. From that we can find this length is square root of 1 minus u squared. We usually just check the positive values. Next, the question answers for the cotangent of cosine inverse u. Cosine inverse of u is theta, so we just have that. And cotangent is reciprocal of tangent, so we have adjacent over opposite. Adjacent is u and opposite is square root of 1 minus u squared. So that is that. Next, we have this problem will be similar to that. First, we will let inside the tangent inverse will give us an angle theta. So let theta be the tangent inverse of u. And then we will take the tangent on both sides because tangent of tangent inverse. We can cancel tangent inverse. We just u, or we write u over 1. And then we draw a triangle. Tangent is opposite over adjacent. So we will let that equal to u and 1. So opposite is u, adjacent is 1. So hypotenuse will be 1 square plus u square, or just 1 plus u square. And then next, sine of tangent inverse of u is just sine of theta, and sine is opposite over hypotenuse. Opposite is u, hypotenuse is 1 plus u squared. So that's what we have. So we let the inverse equal to an angle and then find the ratio, find the opposite, adjacent, and hypotenuse on the right triangle. Once we know those, we know all the trig function, all the trig ratio. This is sine, so opposite over hypotenuse. Opposite is u, hypotenuse is 1 plus u squared. So that's what we have.